Okay, we're going to take a look at solving some of the word problems that we put in our foldable. And the inverse variation we know how to do, so I'm not going to take the time right now. We're going to take the first look at our simultaneous tasks. And remember, this was the one where we had the pipes filling the pool. So we had x over 18 because pipe A took 18 hours. X over 12 because pipe B takes 12 hours to fill the pool, minus x over 8 because the drain was emptying the pool. Okay, so the first thing we need to do is what makes the denominator equal to 0? Nothing. They all have numbers. Step 2, simplify the equation. So I need to find the lowest common denominator for 18, 12, and 4. And the way I do that, I take a look at each number, and this is the way I do it. I break this down into its factors. 18 is the same as 2 times 3 times 3. Right? 3 times 3 is 9 times 2 is 18. 12 can be broken into 3 times 4, but 4 we break into 2 times 2. 8 can be broken into 2 times 2 times 2. So my lowest common denominator will have to contain all of these unique terms. So it must have, let's start here, 2 times 2 times 2, 2 times 2 times 2. Our middle term says we need to have a 3 and a 2 and a 2. I've got 2 2's already, but I don't have a 3 in that lowest common denominator. And my first one says I need a 2, got it. I need a 3, got it. And I need another 3, so we need to add that in. So my lowest common denominator I get from all these unique factors. 2 times 2 times 2 is 8, times 3 is 24, times another 3 is 72. So 72 is my lowest common denominator. And now I need to look, what do I need to multiply 8 by to get to 72? And that is 3. So 3 over 3. 12 needs to be multiplied by 6. So 6 times 6 would give me 72, and I have to multiply the top by that. 8 goes into 72 9 times, so I need to multiply this by 9 over 9. So if we come down here, we get 3x over 72 plus 6x over 72 minus 9x over 72 equal to 1. Okay, let's add these pieces together. 3x plus 6x gives us 9x minus 9x. Uh-oh, that gives us 0. So 0 over 72 equals 1. Zero divided by anything is 0. Does 0 equal 1? It does not. What this tells us is that the pool is never going to get filled if we leave that drain open. So someone better get out there quickly and stop that drain, because this cannot happen. Okay, not a very satisfying problem when we don't get an answer, but that's what happens on this one. Okay, let's take a look at our integer problem. So this was one we set up where we said the reciprocal of the product of two consecutive positive integers equals 1 over 24. And we said that equation was 1 over x times x plus 1 equals 1 over 24. Now since I have a variable in the denominator, I need to check for restricted values. So that means I need to set that equal to 0. X times x plus 1 equals to 0. Since I have two things multiplied together, I separate them. So x equals 0 and x plus 1 equals 0. This one I don't need to solve anymore. This one I would have to subtract 1. So x. So my restricted values are 0 and negative 1. And let's just label those so we remember. We cannot have x equal to 0 or x equal to negative 1. So let's come back to solving. Okay, let's see here. Nothing to simplify on either side. So let's go ahead now and cross multiply. 1 times 24 is 24. 1 times x plus 1 is still x times x plus 1. Now we've reached the point that we actually do need to distribute this x. So we have 24 is equal to x times x is x squared, x times 1 is x. And again, I see I've got a squared term, so I'm going to have a quadratic. So I need everything on the same side of the equation. So I subtract 24 to bring it over. So 0 is equal to x squared plus x minus 24. I don't think this one's going to have a solution. That's not a very good problem. Okay, well let's take a look and see. Can we factor negative 24? So we need things that multiply to negative 24 but add to negative 1. And there are no values that give us that. So this is a bad problem. Okay, well, we've done everything we can. We can set this up. This one will not work. Another bad problem. Sorry about that. Okay, how about rate and times and distance? Got a good problem here for you. Probably the most complicated we'll see. So let's take a look here. Our rate times distance, we said 3 over 20 plus x is equal to 2 over 20 minus x. And as a reminder, the 3 represented our distance going downstream divided by our speed going downstream. And we said that was equal to our distance going upstream divided by the speed going upstream. And the x represented our current. So we don't need to simplify, but we do need to see what is not an acceptable value for x. So our restricted values, 20 plus x equal to 0. If I subtract 20, I get x equals negative 20. So my answer cannot be negative 20. I also have 20 minus x equals 0. So let's add x. So x cannot equal negative 20 or positive 20. Okay, that's easy enough. Those are my restricted values. So now that we've identified those, let's go ahead and solve this problem. So here we go. We've got simple as we can get on both sides, nothing to add or subtract, so we're going to go ahead and cross multiply. Okay, so 3 times 20 minus x is going to equal 2 times 20 plus x. And now we distribute on both sides. So 3 times 20 is 60, minus 3x is equal to 40 plus 2x. Okay, so let's get our x's on the same side. And I'm going to add the 3x. So now we have 60 is equal to 40 plus 5x. Okay, and let's subtract the 40 to move that over. So we have 20 is equal to 5x. Divide both sides by 5. Okay, there we go. We get x is equal to 4. Last step always is to compare that to your restricted values. My restricted values look good. Doesn't equal those. So my solution is x equals 4. And we want to remember that was a speed of the current. So that's going to be in miles per hour or kilometers per hour, whatever our units were to begin with. And I believe in this problem it was miles per hour. So miles per hour. And it's good to get in the habit of writing that in there. Okay.